In this simple illustration of natural selection, we imagine an unsightly blue stain appearing on our kitchen countertop. The stain is caused by the presence of blue dots, but fortunately there's a product available, BlueBeGone, which targets these dots and allows us to clean the stain off our kitchen countertop. We treat the stain with the BlueBeGone, and in fact we do notice an improvement, as many of the blue dots are killed by the BlueBeGone. However, not all of the blue dots are killed, and the survivors go on to reproduce, which brings back our unsightly blue stain. We treat the stain again with the BlueBeGone in an effort to get rid of it, and once again we do notice a significant improvement as blue dots are killed by the product. However, there are a few survivors, and these go on to reproduce. We're beginning to notice that there is a red tinge to the stain now, but we pull out our trusty BlueBeGone and treat it once again anyway. This removes the remaining blue dots from the stain, leaving only the red dots behind, as they are immune to the BlueBeGone treatment. The surviving red dots go on to reproduce, and soon we have an entirely new stain that is composed entirely of the red dots. Further treatment with our BlueBeGone has no effect on this population, because it is now resistant to BlueBeGone treatment. Let us pause for a moment and think about what happened in this scenario. Blue dots were killed by the BlueBeGone. Mutant red dots, which were present in the population initially in only very small proportions, were not killed by BlueBeGone. In each generation, a higher proportion of the population was made up of red dots because the blue dots were being killed off. No blue dot ever turned into a red dot. Only the population evolved resistance, and this took many generations to occur. In the previous scenario, natural selection involved differential survival. In this situation, we begin with a population of blue dots. In each generation, each individual produces one offspring, and then subsequently dies. At one point, a mutation in the parent's DNA results in the birth of an offspring that is different from the parent. In this case, it is red. It so happens that in this environment, the red phenotype confers an advantage. Red dots, as you'll see, produce 2 offspring per generation, whereas blue dots produce only 1. Even though the red dots and blue dots survive equally well in this environment, the higher reproductive output of the red dots results in a change in the proportion of red versus blue dots in the population over many generations. In this case, a mutation occurred which conferred a reproductive advantage in this particular environment. The new red type of dot left more offspring in each generation than the original blue type. No individuals changed from blue to red. One was born red due to a mutation in the parental DNA. Over several generations, the difference in reproductive rate resulted in the new red type becoming by far the most common in the population, again, without any difference in survival rate.